Hello. This video is going to be a kind of a review of rational polynomials to help you prepare for your final exam next week. I've got 9 questions that I pulled from the 3 practice EOC questions. You'll see some continuity or some similarity between these questions, so let's begin. First, this example asks me to simplify this rational polynomial for all values of x for which the expression is defined. First, before we start to work this question, I want you guys to understand this statement for all values of x for which the expression is defined. Hopefully you remember from back in elementary school or middle school that if you have a fraction, let's say a over b, b can never equal 0. What that means is it doesn't matter what's on top, but you can never have 0 on bottom. Okay? You can never have 0 on bottom. So, for instance, this rational polynomial would not always be defined because some values may make this happen, which means it's not defined at that point. So, here's how you work a question like this. Step 1 is we're going to factor. Okay? So I'm going to take the top, x squared minus x minus 6. 1 times 6 is 6. I get 1 and 6. Oh, excuse me. Or 2 and 3. I've got to make negative 1. So I'm going to do 2 minus 3 gets me negative 1. So now I can break this up into x squared plus 2x minus 3x minus 6. Throw in my grouping symbols. I'm going to divide this one by x and this one by negative 3. So in this first pair, I get x times x plus 2 minus 3, because that's what's on bottom, times x plus 2. Those two match, which I'm happy about. So now I have x minus 3. You'll notice I got that from this piece out front and this piece out front. And then I have x plus 2. So that's what the top factors to. Okay. So I know that this is really x minus 3, x plus 2. Okay. I'm going to erase this work so I can have some more space. All right. 2x squared plus x minus 6. 2 times 6 is 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. I've got to make a plus 1, so I'm going to do 4 minus 3. That'll get me 1. So this is going to be 2x squared plus 4x minus 3x minus 6. Throw in my grouping symbols. Out of this one, I'm going to pull out a 2x. Out of this one, I'm going to pull a negative 3. So here I get 2x. Notice that's what's on bottom. Times, when I divide, I'm going to get x plus 2. Negative 3. Notice that's what's on bottom. And when I divide, I'm going to get x plus 2. And so I'm going to have 2x plus 3. Sorry, that's minus 3. And then x plus 2. So the bottom of this is 2x minus 3 times x plus 2. Now the first step was to factor. The first step was a big step. My second step is to simplify. Oh, let me erase that. Don't really know what happened. Okay. So I'm going to cancel what I can on top and bottom. That matches perfectly. The only thing that does that is this x plus 2 and this x plus 2. So I'm left with x minus 3 over 2x minus 3. And there's my answer. Okay. This is pretty much the process we're going to follow, and you'll see that as we go through these examples. So example number 2. Simplify the expression below and state the restrictions on the domain. Now, one thing I don't love about questions like this is it tells us to simplify the expression below, which is what we just did here. We simplified this expression, okay? So that's nothing new. But then it says state all restrictions on the domain. It tells us to do that second. So what I'll have, the mistake that students always made in my class was they would go ahead and simplify like we did on the previous question, and then they would state the restrictions. The process we're going to follow here is we're going to factor. Okay, we're going to state our restrictions, and then third, we're going to simplify. You have to state your restrictions before you simplify. So, we're going to factor this. I'm going to factor a little bit quicker. So 1 times 28 is 28. Factors of 28 that are going to get me negative 11. I've got 1 and 28. That's not going to work. I've got 2 and 14. That's not going to work. I've got 3 and 9. 4 and 7. Okay, so that's going to get me 4 and 7. And then given my negative and a plus, I know they both have to be negative. So I'm going to have x plus 4. Or I'm sorry, I said they were both. I said they were both going to be negative, and I did not make them negative. So I need to have x minus 4, x minus 7. Divide that by 1 times 21 is 21. Factors of 21 that are going to get me 4 would be 7 and 3, but I've got to make the 7 negative because the middle term's negative. So there we go. I factored both of those. And if you need to see better how to factor, let me know. I'll do a video on factoring, but factoring is a sub-skill for this. It's not the whole point. So I factored. Okay. Now I'm going to state my restrictions. Well, the bottom of the fraction cannot be 0. So what that means is, let me see if I can do the magic pen. All right. So what that means is the bottom of the fraction cannot be 0. I don't care about anything else other than the bottom. So what could I put right here that would make this a 0? Well, I know from subtraction that 7 minus 7 is 0. So x cannot be 7. I also know from this that if I put in a negative 3 plus 3 is 0. So x can't be 7, and x can't be negative 3. So x can't be 7, and x can't be negative 3. Well, that's this. I still have the magic pen, so I'm going to have to close that out. X can't be 7, and x can't be negative 3. So, according to this question, or as this is an example, my restrictions actually led me to my correct answer because I didn't have the same restrictions for any two questions. Okay. Now, if I cancel, you'll see why it's that answer. This x minus 7 is going to cancel this x minus 7, and so you get x minus 4 on top, and you get x plus 3 on bottom. So it works out both ways. But there we go. We factored, we stated our restrictions, and then we simplified. All right, next example. It says simplify this rational expression for all values which it is defined. Now this is a case where we're going to multiply, but we're still, number 1, we are going to factor. Okay, number 2, we are going to simplify. And then number 3, we are going to multiply, which is the operation that's going on here. So let's begin by factoring this. So I'm going to take x squared minus x minus 2. 1 times 2 is 2. Factors of 2 that are going to get me negative 1 is going to be plus 1 minus 2. So this is going to get me x plus 1, x minus 2. That's getting multiplied by this fraction over here. And you'll see why I've put this up top in a second. 1 times 2 is 2 again. Factors that are going to get me a plus 2 is going to be x minus 1, x plus 2. This down here is a difference of squares. It's x squared minus 4. So that's going to get me x plus 2, x minus 2. So what I've done now is I have factored. Now it's time for me to simplify. I'm going to cancel. I'm going to cancel everything I can, either vertically or diagonally. So what I'm going to pretend like for a second is that this is over 1. Okay, so now I have a fraction times a fraction. So I can cancel diagonally or I can cancel vertically. So diagonally, I can take this x minus 2 and cancel with this one. Vertically, I can take this x plus 2 and cancel with this one. And all I'm left with is x plus 1 times x minus 1. Now, obviously, if I look at my answers, this doesn't match one of these perfectly. So I'm going to double distribute here. But I also notice that this is difference of squares. I've got the same terms, except this is positive and this is negative. So in this case, I only have to multiply the first and the last. I don't have to multiply my two middle terms. So I can do x times x and get x squared. I can do 1 times 1 and get negative 1. So my answer is x squared minus 1. Okay. Next example. Which expression is equivalent to this monster right here? Ooh, that's a big question. All right, here we go. So 2 times 30 is 60. Keep in mind, I'm sorry, I kind of got started kind of quick. I'm going to factor, and then I'm going to simplify. Okay. So factoring, I've got 1 and 60. I've got 2 and 30. I've got 3 and 20. I've got 4 and 15. And I'm trying to make negative 17, so I've got my combination right here. I can do 3 minus 20 and get negative 17. So on top, I've got 2x squared plus 3x minus 20x minus 30. Throw in my grouping symbols. The reason I'm doing the work on this one is the numbers are big enough that this isn't so easy to do in my head. So I'm working this out on purpose. I'm going to divide this one by x. I'm going to divide this one by negative 10. Pull the x out. I get x times 2x plus 3. Pull the negative 10 out. I'm going to get 2x plus 3. And so I'm glad that those match because they're supposed to. So on top, I have x minus 10. And I have 2x plus 3. Okay. I'm going to erase this to create some room. Uh, 3 times 20 is 60 again. I'm trying to make negative 28, so I've got 1 and 60, 2 and 30. I can make negative 28 out of 2 and 30 if I do 2 minus 30. So I'm going to have 3x squared plus 2x minus 30x minus 20. Throw in my grouping symbols. That's a grouping symbol. Pull out an x here. So I'll have x times 3x plus 2. Pull out a negative 10 here. So I'll have negative 10 times 3x plus 2. So on bottom, I'm going to have x minus 10 times 3x plus 2. I factored. Now I'll simplify by canceling what matches, which is this and this. So I get 2x plus 3 over 3x plus 2. I get b. All right, we've only got a few more examples left. Looks like we have 1, 2, 3, 4, 5 examples left. Simplify this and state all the restrictions. Remember, when it asks you to state the restrictions, the first thing you're going to do is factor. The second thing you're going to do is state restrictions. And the third thing you're going to do is simplify. Okay, so we're going to factor 4 times 9 is 36. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. I'm trying to make negative 12. And I forgot 6 and 6. All right, so I'm going to have 4x squared, because 6 and 6 is my answer. I can do negative 6 minus 6 and get negative 12. 4x squared minus 6x plus 9. Throw in my grouping symbols. Here I'm going to take out a 2x. Here I'm going to take out a negative 3. So I get 2x open for, nope, I forgot to simplify when I took it out. 2x minus 3, negative 3 open 2x minus 3. So on top, I'm going to have 2x minus 3 and 2x minus 3. That was actually a perfect square trinomial, and if I would have realized that, I could have factored that with a pattern and made that quicker, but not the end of the world. All right, on bottom, 2 times 3 is 6. 1 and 6, 2 and 3. I'm making negative 1, so I'm going to do 2 minus 3. So I've got 2x squared plus 2x minus 3x minus 3. Factor, or throw in my grouping symbols so I can do reverse distribution. Here I'm going to take out a 2x, here I'm going to take out a negative 3. So I've got 2x, open, x plus 1. Oh, I forgot my negative 3, so let me erase that. And then I'll have x plus 1. So on bottom, I have 2x minus 3, and I have x plus 1. So I'm ready to state my restrictions. This one right here is going to get me a fraction. I don't know if you've ever seen the pattern, but you can take the opposite of the second number and put it over the front. So I get positive 3 over 2. This is going to get me negative 1. So x cannot be either one of these. So I got positive 3 over 2 and negative 1 as my restrictions. Here's positive 3 over 2. Here's negative 1. And no other answer matches that, so this D has to be it. And if I go ahead and cancel, you'll see that's what I end up with anyway, is 2x minus 3 over x plus 1. Next question. So we're asked to simplify this. That's being multiplied, so the same thing is going to take place that we did before. We're going to factor everything. We're going to simplify. And then third, we're going to multiply. Okay, so this is pretty simple to factor. 1 times 12 is 12. Factors of 12 that are going to get me 7 are going to be negative 3, negative 4. So this factors to x minus 3, x minus 4. That's over x plus 4. Now, one way they like to try to throw people off is they'll do one of these that's backwards like this. Okay, so what we're going to do is we're going to reverse the order, which means this is going to be negative x plus 3. And the reason it's written like this is so that the subtraction comes second. But we're also just going to pull out a negative 1, which will allow us to put it in the order we want. Okay, so then we're going to have x minus 3, because it changes my signs when I pull out a negative 1. Now you'll notice that this matches this up here. Okay, so I factored. Now I can simplify. So this x minus 3 cancels that x minus 3. I'm going to do x minus 4 times 1, which is just going to get me x minus 4. And then I'm going to do x plus 4 times negative 1, which is going to get me negative x minus 4. And then I'll have x minus 4 over negative x minus 4. Oh, I'm so sorry. Wait. I'm not sorry. Here's what they've done. Okay, so my apologies. What they did was I left the negative 1 on bottom to get negative x minus 4. They didn't do that. Okay, what they did was they brought the negative 1 up, which doesn't matter ultimately, but I just want you to understand why the answer is C. Okay, so if I do negative 1 times these two items, I'm going to get negative x and a plus 4. So I'll rewrite that in the opposite order, get a negative x and a plus 4. And then on bottom, I'll just have x plus 4. So I guess they just think that one looks the prettiest, which to me is whatever. But that's the justification on why it's C and not what I had written originally. Okay. All right. Next example, we're asked to simplify this and state all the restrictions. Keep in mind, we're going to factor. Then we're going to state our restrictions, and then we're going to simplify. Okay, don't forget the order. So I got to factor this. The top is factoring by reverse distribution, so I'm just going to pull an x out, and I get x minus 2. The bottom is factoring a trinomial, so I'm going to do 1 times 8 is 8. Factors of 8 that get me positive 2 are x plus 4 and x minus 2. Now I'm going to state my restrictions because I just factored. X cannot be negative 4. Cannot be negative 4 because it would make that 0. And it cannot be positive 2 because it would make that 0. So negative 4 and positive 2 is right here. So obviously this is my answer, but let's show it. If I cancel this and this, you'll see the only thing I'm left with is x over x plus 4. Okay. 2 more examples. It says, which expression is equivalent to this for all x not equal to 7? This is a restriction, and if you look, 7 minus 7 would get me 0, so it tells us that x can't be 7. It all makes sense if you just try to stop and see the connections. Now, this is not going to change the way that we solve the problem, but I want you to understand why this is written there. I have a lot of students that miss a question because they see something like this, they don't know why it's there, they get confused, and then they just kind of give up. So just don't give up. It's there for a good reason. So I'm going to factor the top. So this is going to be a factor and a simplify. So 1 times 49 is 49. Factors of 49 that get me negative 14 is negative 7. So x minus 7 over x minus 7. So this is going to cancel with this, and I'm just left with x minus 7. Okay, that one's a pretty straightforward one. Last example. Simplify this nice pretty thing. Okay, so I'm going to factor. Since I'm multiplying, I'm then going to simplify. And then last but not least, I'm going to multiply. Okay, 4x squared won't break down, so I'll leave it alone. This is difference of squares, so I get x plus 5, x minus 5, times, this is going to get me x minus 5 because that doesn't factor. This is reverse distribution. It looks like I could pull out a 4x times 2x plus 3. Okay, so I factored. Now I can simplify. This 4 cancels out this 4. This x cancels out one of these x's. This x minus 5 cancels out this x minus 5. So I'm going to rewrite this just so this looks pretty. So I've got an x here over an x plus 5 times a 1, because all that stuff went away, so it's 1, times 2x plus 3. Now I'm ready to multiply because nothing else cancels. Well, x times 1 is x on top, so I know it can't be b or a. And then on bottom, I'm going to have an x plus 5 and a 2x plus 3. So it's got to be d. So what I hope you noticed is that these questions aren't terribly difficult if you're good at factoring. If you're not good at factoring, you really need to brush up on those skills, because being good at factoring is going to make these types of problems much easier. So I hope this helps you prepare for your final exam, and good luck to everybody.